Welcome back to another explainer. Okay, let's dive into this. Have you ever noticed how, incredibly brilliant AI coding agents can be when they're generating code, but then they get utterly lost when trying to read the actual documentation that goes with it? It's like they hit a brick wall. There's this massive communication gap between the AI agents we rely on every single day and the external, deeply structured docs living in GitHub repository wikis. So today, we're going to unpack a really specific, totally fascinating solution to that exact problem.
I mean, think about it for a second. How do AI agents actually read GitHub wikis right now? Well, the reality is, large language models natively struggle with this. It's not like they can just open a web browser the way you or I do to navigate those complex, multi-page Markdown layouts. If you try to force an LLM to just ingest structured repo docs directly from a standard web interface, you usually end up with this messy, completely disjointed context window. And that's a huge pain point, right? Especially if you're trying to get your AI agent to really understand a project's deep lore and architecture before it even starts writing pull requests.
Which brings us to Section 1, Introducing the deepwiki CLI. Query via terminal.
So to let you query all this without a browser, this brand new Rust-based command line interface relies completely on MCP. That's the Model Context Protocol. If you're not super familiar with it, honestly, just think of MCP as a universal translator. It takes all that raw external data, like the intricate folder structure and the text of a GitHub wiki, and packages it up into high-quality, perfectly formatted context that large language models can instantly digest. It's literally the crucial bridge that allows deepwiki to speak directly and fluently to our AI agents.
The backend architecture here is incredibly streamlined to make all this happen. deepwiki connects directly to mcp.deepwiki.com using that Model Context Protocol just over a standard HTTPS connection. And what's absolutely fantastic for your workflow efficiency is that there is absolutely no authentication required to query public repositories. None. It's completely frictionless, out-of-the-box access to open-source knowledge.
The actual functionality is broken down cleanly into 3 core tools. You've got Ask Question for AI-powered Q&A on specific inquiries, Read Wiki Structure to grab the overall layout and topic list, and Read Wiki Contents to pull the full text. So the crucial point is that each of these commands is a single, stateless query. There's zero ongoing conversation state preserved across invocations by the app. If an agent needs to ask a follow-up question, it simply runs another ask command targeting that exact same repo. It's designed to be highly atomic and, honestly, incredibly fast.
Now let's transition right into Section 2, Under the Hood with Rust, a mechanical code review.
Okay, so deepwiki actually serves 2 very distinct masters, and the code reflects that beautifully. Notice the stark difference in priorities here. For the human user operating the CLI, the code implements visual feedback, specifically a little terminal spinner, so you know exactly when those remote network calls are processing. But for an AI agent, visual spinners are just useless garbage data. So instead, deepwiki ensures a consistent Markdown header output, like ## deepwiki:repo. This guarantees the text is perfectly formatted and heavily optimized for parsability by downstream agents like Claude. It's a really smart dual approach.
And this brilliantly illustrates the exact components making this all happen. Here is our Rust dependency map. You can kind of think of these individual crates as engine parts working in perfect harmony to assemble a very lightweight CLI. Clap handles routing your commands. RMCP manages the heavy lifting for the Model Context Protocol. Request is the HTTP client making the actual network calls, powered asynchronously by the Tokyo runtime. Then we've got Indicative providing that human UX spinner we just talked about, and Serde seamlessly serializing all the tool arguments into JSON behind the scenes.
Pulling all of those dependencies together, here is the step-by-step execution lifecycle of a single query, which is orchestrated primarily inside the lib.rs file. First, the application uses clap to parse exactly what tool you asked for. Second, it starts up the indicative spinner. Third, it opens a brand new, fresh MSCP connection using RMSCP and request. Fourth, it sends a single, dynamically constructed JSON tool call. And finally, it prints that LLM-friendly Markdown result and simply exits. It's clean, it's async, and it's highly efficient.
Which brings us to Section 3, the default security trade-off. A look at the default configuration. Take a look at this explicit warning pulled directly from the source's documentation. Now, what's really interesting about this slide is the why behind this decision. Why on earth would a modern tool explicitly disable TLS certificate verification right out of the box?
Well, it's because AI coding agents very often operate in highly isolated, monitored sandboxes. These environments utilize intercepting proxies to track exactly what the agent is doing for safety reasons. If deepwiki enforced strict certificate checking by default, the proxy would block it, the network request would completely fail, and the AI agent wouldn't be able to fetch the wiki at all.
But don't worry, security-conscious learners, the developers absolutely thought of that. Actually, you can easily toggle the security right back on. By simply setting the environment variable, deepwiki TLS verify, to 1, the tool immediately restores strict TLS validation. So, it's a highly calculated trade-off designed specifically for AI environments, but with a very easy opt-in for standard secure human usage.
To wrap up the practical side of things, getting deepwiki running in your own environment is incredibly straightforward. There's a homebrew formula ready to go for macOS ARM64 users, and a standard cargo package configuration if you prefer building it directly through Rust's package manager. And, beautifully tying back into its primary purpose, it actually ships with a ready-to-install Claude code skill located right inside the repository folder. This makes agent integration practically plug-and-play.
Which leaves us with one final thought. We've seen how deepwiki brilliantly bridges the gap between raw, structured knowledge and the context windows of large language models using the Model Context Protocol. It solves a very real and, let's be honest, very frustrating bottleneck in modern AI development. So, with this tool now at your disposal, what repository wiki will you empower your AI agent to read next? Thanks for joining me on this explainer. I highly encourage you to go test this tool in your own workflow just to see the difference it makes. Keep learning, and I'll catch you on the next one.